Okay, so we'll now look at a Julia code for how to use data frames with like a business kind of application. So again, you'll be required to include these packages in this code. So let's create these vectors like this. The brand gains a vector of strings. There are three strings here: company A, and B, and then the tire, premium, economy, standard, and the quantity of the product they're producing, 10 units, 100 units, 550, and so on. Price per unit, 110 and $50, and the cost to produce them, $30, $7, and $25. Now, so we have not created a data frame. So in the previous video, we saw how to create a data frame from loaded to a CSV file. And also we saw how to generate a matrix out of the data frame. And then using this matrix, we can generate a data frame back, a second data frame, and we could rename, have the column names to be kind of what we want. So in this code, we will look at how to create a data frame through a table that we create as part of or generate as part of the code. So this is the table that we could generate now based on these vectors that we created. So table is again a class in this type table package. And this is like a constructor, and you're passing. So this left side names or the column names in the table, and the right side names or the vector names that we have created here. So brand, tire, quantity, all the lowercase names or the vector names that we have created here. So they are passed on the right hand side, and the brand, tire, quantity, price, cost or the column names for this table. Now we can now call this data frame constructor and pass this my table as the argument to it. So the column names will be automatically brand, tire, quantity, price, and cost. And so this is the constructor, and it will return an object of the class data frame. So it's my data frame, so I can name it whatever I want. So if you want to look at the table-based data frame that we just created, it should be here. I have already run it. So the my table-based data frame has 3 rows because if you look at it, you have only 3 records here. So each record will be for a row, company A, and B, then premium, economy, and standard. Then the quantity column will be like 10, 100, and 50. The price column will be 110 and 50, and the cost will be 37 and 25. Now, since the values for these three vectors like quantity, price, and cost are written without any decimal point, they are the Julia environment is treating them as integer columns. And then these are enclosed within double quotes. So automatically these two brand and tire columns are treated as string columns. Okay, so that should be fine for now. And now what we want to do is we want to generate some more columns. So we want to generate, say, a revenue column based on, so this is another way we can access the columns. Again, in the previous code, we passed the column names in this syntax. Now we could pass the column number in this like this. So third column, that's what it means. And all the rows in the third column, when you put colon, comma, 3. So let's see, what's the third column? So the third column is going to be the quantity column, and the fourth column is going to be the price. So if you multiply the quantity times price, again, the quantity is the number of units you're producing, and the price is the price per unit. So when you multiply the quantity times price, you will get the revenue that you get across all the units that you produce. So that's what we are doing here. So I am creating this revenue again, like we did in the previous code, like no, not yet. Yeah, we did like that IDs thing. So if you're creating a column that's not there, just call it on the data frame object itself. So the revenue column is not there. So you call that on the data frame object itself like this, my data frame dot revenue, and that will generate the new column. And you want to assign the values to that column. You want to assign the values to each row in that column. So use the dot operator like a broadcast operator, and you retrieve all the values in the third column by using this column, and you want to apply on each of those retrieved rows the multiplication. So use the dot again there, dot star, and you want to multiply with the values retrieved for the fourth column. So multiplying the quantity times price and assigning that to the revenue column. So if you now print the my data frame, this is how it looks like. Now, since you're again multiplying two integer values, columns in quantity and price, the revenue column is also treated as an integer. So it's 10 times 100 is 1,000, 100 times 10 is 1,000, 50 times 50 is 2,500. All right. Now, this is again, so there are how we could access the column. So one is using the column number. Now back to accessing the columns using the column names. So now what we want to do is get the profit. So the profit is uh, the difference in the price per unit and the cost per unit, cost to produce per unit, and you multiply the difference with the quantity, you get the profit. So again, the profit column is not there as of yet. So you just go ahead and right away create my data frame dot profit and do this assignment here, and that will generate a new column profit, and they will get added to the end of what is currently in the data frame. So the revenue column got added to the data frame, and now the profit column will get added. So again, you want to assign to all the rows in the table in the data frame. So you say dot equal to, and then this column will retrieve all the rows, and then this is the syntax for accessing using column names dot quantity in this case, and then dot star. So you want to multiply each of those quantity values across the rows with the difference between the price per unit and the cost per unit. So the price is the price that you're selling per unit. And again, you're taking the difference across each row. So you say dot minus, and then the cost to produce per unit across all the rows. And so that will be the profit column. So price minus cost is like 100, 100 minus 30 is 70 times 10, which is 700. That's the profit. And 10 minus 7 is 3 times 100 is 300. That's the profit. 50 times 25 is 25 times 50 is 1250. That's the profit. So now you can print the data frame. So now you could write this data frame to a CSV file. So in the earlier code, we saw how to read a CSV file as a data frame. So now we are seeing how to write a data frame to a CSV file. So this is a syntax for that. So CSV is a package name dot write. And then you could pass any name you want to pass as for the CSV file you want to create, and comma my data frame. So the data frame whose content will be now stored in the CSV file. On the left-hand side, again, this is just a user-defined name that you want to come up with for the object of the CSV file. Okay, so this CSV file will be created in the same folder in which you're running this Julia code. Okay, so now you want to sum some columns like the profit column, revenue column, and quantity column. So you can call the sum method on these columns. So another way you could access, so if you just say the data frame name dot the column name, that will be like a vector. So the profit values will be retrieved as a vector, and you're calling the sum function passed to which the vector is passed. And then similarly, the revenue column and the quantity column. So what we could now do is create a 1 by 3 matrix of just these totals. So it will be just one value, the total profit, the total revenue, total quantity, just be one value for each of these variables. So I'm just going to create a 1 by 3 matrix. So it will be one value here, another value here, and another value here. So this is the syntax you could follow if you just want to create a matrix based on some scalar quantities. Okay, so the totals is the matrix name now, and just put in the square bracket and pass the scalar quantity names. Now you could create a second data frame based on this matrix we just created. So data frame and the totals is the matrix name. Now you could pass the column names you want. We'll do that later. But as I said earlier, if you don't pass the column names, you could pass column auto. That's like a keyword. So you let Julia to pick the names for your columns in the data frame. So if you look at, if you print the second data frame comprising this total values, since you didn't pass the column names, Julia picks up like x1, x2, x3. And all these were integer variables because the sum is like integer without any decimal point. Okay, so now what we want to do is we want to rename these columns of this second data frame we just created. So this rename function is a function that you could call to rename the columns of a data frame if you want. Again, this exclamation mark will enforce the renaming on the data frame in which you're calling, that is passed as argument to the rename function. And so the second data frame is the data frame we just created. And so this is like a vector of the names you want to pass for your columns. So we could have created the second data frame right here with this vector, but I just want to show the use of this auto variable that could be used to let Julia itself to come up with the column names. And then there's use of this rename function that could be used to rename the columns of the data frame that you have already created. Okay. So after renaming the columns, you could print it out like this: the total profit, quantity, and total revenue. Now, so we could create a matrix now that has the individual revenue and profit values for the three brand and tires. Okay, so what I'm trying to do is this. I want to create a matrix that has these columns from the data frame. So now you're back to working on the my data frame, which was the original data frame that has all these columns that we have created. Okay, so this is the my data frame. Now, so I want to take the brand column. This is how we did. So again, this will get a vector, my data frame column, comma, column brand. So all the values in the brand column, all the values in the tire column, revenue column, and profit column. So, and again, this is a matrix I'm creating first. So the syntax is similar to this syntax. Where you have the scalar variable names. So here there's a vectors, but again, there's no comma in between the column names. You just leave a blank space. And then, so you create the custom matrix. And then you want to create a third data frame by calling this data frame constructor and pass the custom matrix we just created with this three column or with these four columns. And you pass the names here right away. So using the column auto, just pass the names you want to have for these four columns in the third data frame. So if you now print the third data frame that we just created, this is how it looks like: the brand, tire, revenue, and profit. Now, you could describe the third data frame. So now this data frame has some string columns as well as some numerical columns. So let's see what the described function is showing up for the different statistical parameters. Okay, so the mean is not computed for string columns, only for the integer columns. And the minimum is computed for the integer columns, quite straightforward. But now for the string columns, the way the minimum is computed is like lexicographic ordering. So company underscore A, company underscore A are the same, then company underscore B. So if you sort them in how the word will appear in the dictionary, company underscore A will appear first, so that will be the minimum. Maximum will be company underscore B. Similarly, if you sort these three words, Out of these three words, economy will be the first to appear in the dictionary, so that will be is the minimum, and standard will be the last to appear in the dictionary, so that will be the maximum. And there are no missing values. And then the data type is not listed as string for the anything, the brand entire, as well as for revenue and profit is not listed as int. So let's go back and find out why it's listed like that. So if you see here, you're creating it from here. Okay. So so this is retrieved as a vector. Okay. So this is retrieved as a vector from this my data frame. And somehow the data type of that column is not captured. The my data frame here, it is captured as a string everywhere on the top, but for some reason I'll find it out and update you if I find the reason. So it is captured as string and integer all over here because the values are integers and strings. But somehow when you retrieve those columns from the data frame, create a matrix out of them, and then use that matrix to create a new data frame, that the data types are not getting transferred. So they're just getting stored up as any data type. But I think that gives you more flexibility because you could treat them as a float now instead of just using as integers. As you can see, the mean, and median are now printed as a float instead of just an integer. Okay, that's a very small issue that you don't need to be worried about. So the main thing is we are looking at how to create a data frame using different vectors. So first, you're setting up a table based on those vectors, and you can again on the left hand side have the column names that you want in that table, and that will automatically get transferred to the column names for the data frame that you're creating based on the table. And then you can access the columns of that data frame using the column numbers and what column, third column or fourth column they don't look at. And then you can use this dot operator as a broadcast operator. So if you want to multiply the values of two columns, you can use dot star and say my data frame colon comma 3, that's the third column. And then this will become the fourth column. So the colon for the row index means you're retrieving all the rows and multiplying each row with the multiplication operator and assigning back to a new column that you're creating to get generated out of this multiplication. And then you can write that data frame to a CSV file using the csv.write function. And then you can create a matrix based on just some scalar quantities. And using this matrix, we can again generate a second data frame and whose columns could be initially named like auto by, I means let Julia to name the columns, and then we can rename the columns using the rename function. And then you're creating a second matrix, a custom matrix using some columns from the original data frame. It's a mix of string and integer values. I think that may be the reason because matrix typically you expect it to be of a certain data type, a matrix of integers or a matrix of strings or a matrix of float. But since you have a mix, this is vector of string, this is another vector of string, but now you have a vector of integer for the revenue and a vector of integer for the profit, you have a mix. So the data type of this matrix is any, and it's because you cannot say this is a string matrix because only two of the four columns are string and only two of the four columns are integers. So we cannot say this matrix is of a particular data type. So it is created as a data type, a matrix of data type any. And because of that reason, the data frame that you create out of that matrix, for all its columns, the data type will also be set as any because the underlying matrix is of type any. Okay. And then you can kind of process this data frame separately you want, uh, depending on what you want to do with this data frame. So this is a subset of the my data frame basically. Okay. Stop this video.